Hey students, I wanted to cover maximum error one more time before we got into the test, and just wanted to, one of those things where it's really easy math, but it's just kind of hard to really grasp the concept. So here we go. How do you find the maximum error? Well, in this case, we're going to compare the volumes of a rectangular solid. You want to take the maximum volume, or the maximum measurement, the maximum perimeter, the maximum area. In this case, volume. You want to take the maximum that it could be and then divide by the rounded amount, in this case volume. So we're doing the volume of a rectangular solid. So here's one already pre-made. Now it says, I said this, all of these values were rounded to the nearest inch, which means they could be plus and minus a half inch in real life. So what the book wants you to do is they want you to find the smallest volume, compare it to the rounded, and then the largest to compare it to the volume. Well, spoiler alert, it's always going to be the biggest. The bigger one, the overestimated one, is always going to be the worst you can do, okay? So let's see what the worst we could have done is. So again, these were all rounded. So what's the worst possible case scenario? Well, let's find the max volume. What could it actually be in its maximum capabilities? Well, all you do really is you add a half inch to all these. Why add a half inch? Because it says rounded to the nearest inch. So that means the worst you could be off is up and down a half inch, up and down a half inch, up and down a half inch. But we all know, like I just said, the larger is always going to be worse, or more off, so to speak. So all you do mathematically is, I've already calculated the volume of the rounded, excuse the bell. All you do is you add a half inch to everything and see how big that volume is. So here we go. So what if it was 8.5 by 18.5 by 6.5? So that would be the maximum value that it could actually be. Again, these are all rounded. They are not accurate because they were rounded. What could it actually be? We're doing like worst case scenario down here. So let's go. So you can do it all in your calculator in one spot. So all you do is add a half inch to all the dimensions. 8.5 times 18.5 times 6.5. Let's see what happens here. So 1022.125. I like to be accurate, so I'm going to write it all down. 1022.125. Right, so there we go. That's the worst case scenario. That's what the volume could actually be. So as you can see, rounding to the nearest inch is kind of lethal if you round down. If all of these were a little bit bigger, a little bit bigger, a little bit bigger, you could be off by quite the amount. So let's go ahead and see what the percentage is. How far off are we? Well, let's take the maximum volume of 1022.125, divide by the rounded, which was 864. Okay. So again, anytime you do a division here, obviously it's going to be an overestimation. So it's going to be 100 and so many percents. Well, that's so many percents over 100. That's going to be our answer. So see what it is here. It's already in my calculator. I do kind of it all on one screen here. 864. So if I round that to the nearest percent, this is actually 118.3%. So I'm going to keep it at 118. So that's 118% approximately. So how far off were we, students? Well, the worst you can do is you could be 18% off. Okay, you can have an error of 18%. So what is that saying? That's the worst you can get. The worst you can do is if all of the measurements were a half inch bigger, because you rounded the nearest inch, if all of the measurements were a half inch bigger, okay, you'd be off by 18%. That's all it's asking. So the math of it is actually kind of simple when it comes to the volume. You find the volume of the rounded. If it says nearest inch, you add a half inch to all the dimensions. You find the hugest, most possible largeness, I love making up words, that the volume could be. Then you divide and you figure out how much bigger it is. It's 18% bigger. You could be 18% off in this situation. Okay, so kind of replay it through your mind, push pause, rewind, watch it again. All of those fun things. Again, why don't we go down a half inch? Because if you do this over and over and over again, taking a half inch away from these dimensions is not going to be as big of a move as adding a half inch to all the dimensions. So that's why the larger, the maximum, is always going to be the worst you could do. So, end of story. Bye-bye.